Alright, y'all, here's an explanation of that problem. Now, this problem is a perfect example of why we use variables. Okay, let me go pull it up. I'm sure some of y'all tried not to use variables. How successful was it? These kind of problems were from the Middle Ages and on. You know, you can imagine people sitting around a table having a festivity, and somebody stands up. I have a problem that I would like to give the audience. And they would do this, entertain themselves. They didn't have TV back then, right? So they would have little actors dancing around, people playing violins or musical instruments to provide entertainment at these galas. And so a scribe would stand up and pose this problem. It seems that a humble merchant visited 3 fairs. At the first fair, early in the morning, he doubled his money selling his products, but spent $30 in food and buying other items. Okay, I know the accent sucks. Just trying to keep it fun, y'all. So after the first fair, he doubled his money. So we get twice this. But he spent $30. Okay, so this is what we have as total money after the first fair. Now the second fair. At midday, at the second fair, he tripled his money and spent $54. Okay, so he tripled this, right? Oh, but what did he do? He spent $54. All right, so let's simplify this. Okay, so now that's the expression for how much money we have now. At the third fair, in the afternoon, he quadrupled his money, but spent $72. Quadrupled. Oh, that's a big word. That means quad, right? Multiply by 4. And then spent, what, 72? All right, so multiply this by 4. Let's see, 400 on 60, 16. 400 on 60, 16, right? All right, now let's simplify that. So this would be 640 plus 8. Am I right about that? Upon his return home to his wife and 10 children, yeah, they had a lot of kids back there in the day, 10. Ooh, can you imagine? Late that day, he counted his money he had in his bag, and it was $48. So this is $48. All right, so then we just solved that equation. You guys can do that, right? Right? All right, so you do that, and you wind up with, I did this problem earlier, you wind up with 48 bucks. Woohoo! Oh wait, no, you wind up with, my bad, 29 bucks. Alright, so how much did he make? Well, after the third day, he had 48 bucks. He started with 29. Right, so he made 19 bucks. So that's how much profit. Now, in business, you like to express your profit as a percentage of the original, right? So you can kind of see growth. Okay, yeah, we made 19 bucks, but if we started with 10 billion, that's pennies. Yeah, we made 19 bucks, but if we started with 1 million, yeah, that's not too much. Yeah, we made 19 bucks. We started with 29. Wow. That's more than half. All right, so what do? New minus original, right? So 19 over the original, which is 29, equals the number per 100. And so when you do this, you wind up with 65%. And if you wanted to create a growth factor, all right, and so if you multiply that to the previous value, so say he does this again, right? So now he has 48 bucks. if you assume the same rate of increase, then you multiply 48 times 1.65517, and he'll have 79 bucks now. So every round that he does this, assuming the same percentage of increase occurs. And that's not always a guarantee because, you know, different market forces, different factors, you know, maybe some of the things he's buying and selling are shortage, so he has to spend more money to get them, or maybe there's an abundance of the things he's selling on the market, so then he's going to get less money for the things he sells. You know, this is a market economy. We're not talking about corporations and bureaucracies here, right? Oh. Anyway, that's how you do the problem. Y'all take it easy.